In this lecture, we will see the different ways we can use provisioners in Terraform. In the previous lecture, the remote exec and the local exec provisioners we used run tasks when a resource is created. This is the default behavior and is known as the creation time provisioner. Let us use the same example of the local exec provisioner that we used in the previous lecture. When applied, the provisioner will record the public IP address of the web server on the local machine. We can also make the provisioner run before a resource is destroyed. This is called a destroy time provisioner. This can be specifically set by making use of the when argument and specifying its value as destroy like this. Another default behavior of a provisioner block is to cause a Terraform apply to fail if the task specified in it fails for any reason. For example, if the creation time provisioner that we used earlier makes use of an incorrect path in the command, the default behavior would be for the Terraform apply to fail with an error like this. Here, there is no /temp directory located in the local machine, and this results in a failure. The same behavior can be specified by adding an onFailure argument in the provisioner block with a value of fail like this. This is the default value, so it's not really required to be set. Please note that when this happens, Terraform marks the resource as tainted. We have a lecture on resource taint in the following section. We may not always want the apply step to fail if the provisioner fails. For example, let's say the provisioner script is optional and we don't care if it fails. We want the apply step to ignore this error and proceed. To override the default behavior and for apply to go through successfully, use the onFailure argument with continue as the value. When we run Terraform apply now, the resource will be provisioned successfully. Well, that brings us to the end of this lecture. Let us now look at some of the considerations to keep in mind while making use of provisioners. We learned how to use provisioners in Terraform in the previous lecture. While they are great for running tasks such as a bootstrap script using remote exec, Terraform recommends to use provisioners sparingly. And this is because of a couple of reasons. Making use of provisioners increases the complexity of the configuration. And since we can basically run any system-supported command within the command or inline argument, Terraform plan has no way to accurately model the actions of a provisioner. Secondly, as we saw in the example of remote exec, a connection block must be defined for some provisioners to work. This means that the network connectivity from the local machine and the authentication must be established before the provisioner is run. And this may not always be desirable or feasible. In order to avoid this, Terraform recommends to make use of provisioners that are native to the resource. We already saw an example of this when we used user data while creating the EC2 instance with Terraform. User data is a native feature of AWS EC2, and it runs during the instance launch time without having to define the connection block. The user data argument is specific to the AWS EC2 resource, but there are similar arguments for other cloud providers that can be used in the same way instead of using the remote exec provisioner. Some of these options are listed here. As a best practice, it is recommended to keep the post-provisioning task to a minimum and build custom images that will have all the software and configurations required for a resource beforehand. Following the same example as before, instead of installing Nginx during launch time using user data or remote exec provisioner, make sure that we use a custom AMI of Ubuntu which already has Nginx installed. And this is where templating tools come into the picture. We can build custom AMIs either from an existing instance that has all the software and configuration installed, or make use of tools like Packer, which can do this in a declarative way. Once this image is built, we can use it to build an AWS instance, and this time there is no need to use user data or remote exec provisioner to install Nginx.